Okay, we're still sorting out a couple of technical things, but I think now we're fine. Again, as you probably all know, ASAP East Africa is a program funded by DFID, East African Research Hub. So this program brings together UK and East African researchers in air pollution, urban planning, economy and geography, public health, social sciences, and development studies to provide a framework for improved air quality management in East African cities. We are also very pleased to welcome participants from India, and those participants will be joining the next 4 webinars as part of the new GCRF networking grant. So today we are very pleased to have 2 presentations from our research partners at the University of Birmingham and at the Population Council in India. Our first presentation, which is going to be delivered by Professor John Bryson from the University of Birmingham, will be focused on urban diagnostics and the management of air quality in developing countries towards an integrated approach. This is very much linked to the 2 work packages he's leading with me, and also with the work that our new research fellow, Hakim Bakare, is doing. The second presentation will discuss population dynamics, air pollution, and public health, and will be presented by Dr. Bitu Mahapatra of the Population Council in India. So this webinar, again, as you may already know, will be recorded for academic use, and at any point during the presentation, please feel free to type a question in the chat box. So this is the speech bubble at the top center of the screen. We will collect all these during the talks and put a number of these to the presenters. So without further delay, I'm going to pass over to John for our first presentation.
Right, thank you, Lauren. I've got to advance it here. Right, okay, brilliant, thank you. So we have this very long title, Urban Diagnostics and the Management of Air Quality in Developing Countries Towards an Integrated Approach. And what I want to do this morning is 3 things. Or 4 things. First, introduce again our research fellow who joined us 2 weeks ago last Friday. So he's still in that moment where we've thrown him into a rather cold swimming pool and asked him to swim fast. And he's delivered 2 things in the 2 weeks. You will note from the website that there's a reading pack that was uploaded earlier in the week that is linked to this presentation. That was Hakim's first task. And his second task was to provide the outline for this presentation. So the overview of this presentation is we want to do 3 things. One is to do a very brief summary of some of the impacts of air pollution from a systemic and more holistic way that's coming from the academic literature. Second, to focus on lessons from the United Kingdom and basically tell you what doesn't work here. So what you shouldn't do in emerging economy contexts. And thirdly, to present some of the background for what work packages 1 and 3 are going to be doing within the ASP project. So to start with the overview, this has locked itself. Right, so overview. So we need to, so the argument that we have within ASAP is that if we want to actually deal with air pollution, we need an alternative approach to policy development and to the science. And that alternative approach is something which is more holistic, something which is more systemic. So if we want to understand why air quality management policies tend to fail, they fail because of governance issues. There's a displacement between national government and local government in where that policy is being enacted. They fail because we have air quality policies that sit aside some of the core policies, for example, linked to transport, linked to economic planning and spatial planning. Now, what do I need to do here to? So I need to click back on that. If we look at the literature on air quality management policies, what we see is lots of missed opportunities. The UK being a relatively developed economy, depending on which debates you want to lock yourself in, because bits of the UK are quite emerging, bits of the UK are very, very developed. But even within the UK, 62% of UK local authorities still have major problems with air quality. We have significant numbers of deaths within the UK, and of course the European Union, we still have 23 member states that are still in breach of some of the air pollution regulations. So asking emerging economies and East African countries to tackle air quality in a sophisticated way is really a big ask if we can't do it within the United Kingdom. So we have a whole series of issues to do with attributable deaths coming from particulates, coming from various issues to do with air quality and air pollution. And I suppose the key thing with this slide is the quote that's coming from the World Bank. So air pollution, it's a health issue, but it's also an economic issue. And that economic issue is about productivity. It's a drag on productivity. It's a drag on income. So one should never treat air quality and air pollution as a minor issue. You should also see it as a key economic issue, a key connectivity issue, and a key health issue. So that gives one an indication that this is about developing cross-cutting policy rather than developing a sort of sidelined air pollution policy. We have a slight technical issue here. Right, so what we now want to do is just move on to some of the lessons from the UK. So we must first remember that the contexts are extremely different. So within the world of policy, ideally one shouldn't copy from one country into another country, because you're going to have different causes and drivers producing different challenges and different issues. So copying policy tends not to work, so we need local policy to meet local contexts. We also have issues in terms of access to different types of data sets, access to different approaches to engaging in governance, and aspects that are different in terms of the ethical issues that are linked to policy development and policy enactment. So the lessons from the UK is that while we can argue there has been significant improvements in air quality, there are still significant issues and significant barriers. Now, there is within the reading pack, we identify a set of papers that review British air management policy, and all of those papers identify a series of common problems. So one of the first common issues is the level at which policy is enacted. So if we take a city like Birmingham City Council is in control of certain policy arenas that will impact on air quality, like spatial planning and like local connectivity and local movement, but it's not in control of things like the motorway network and in things like any pollution that's coming from the railway network, because those systems are operating or being governed at a different policy scale, a national scale rather than a local scale. The second issue we have is the absence of any legal obligation to actually deal with some of the issues related to air quality, and the legal issues either sit nationally or they sit at a European level and sometimes sit at a local level. And again, that links back to this issue about the spatial scale at which air quality is dealt with in a country like the United Kingdom. And then the third issue is that there's an ongoing process in the UK to try and devolve various activities to the local level, but that devolution doesn't come with, in some cases, control of money or control of some of the more national drivers of air quality. So the local becomes responsible but has limited control over some of the drivers of air quality pollutants. So from the UK, what we need to try and do, or what the UK is beginning to try and do, one is to ensure that air quality becomes a fundamental local government responsibility. So we're seeing that within Birmingham with the discussions and debates over putting in place a clean air zone within the city, and that's a very politically difficult issue at the moment in terms of the boundaries are. The second issue is, as Lauren moves me forward, the second issue is to try and integrate air quality across all policy areas. So if you want to have an effective air pollution policy, the first thing you need to do is not have a policy for air pollution. What you need to do is make sure that your transport policy is compliant and is not producing too much damage to air quality. Economic policy is also compliant and is not producing too much damage to air quality, as is your connectivity, your health policies. All of those need to have within them an issue that deals with air quality. If you sideline air policy into a beautiful, superb, sophisticated air policy, the likelihood is that will have very limited impact. So that's the one thing you shouldn't do, using some of the lessons from the United Kingdom. So I need to do whatever this does. Now, oh, you've got a better finger than me. Right, good. So the local air quality management policy in the UK is strong, but the problem is centrally driven, it's process heavy, it's cumbersome, it's not integrated. We have difficulties with interdepartmental collaboration, otherwise meaning it's siloed. So bits of the air quality issue are owned by different departments with limited dialogues between those departments. And ultimately, the key issue is failure to integrate and the failure to develop what I call deadly policy. So deadly policy is policy that sits across many different policy agendas. And what that means is it's deadly because if there's a change of government, it's very difficult to remove that policy. Because to remove that policy, you have to actually rewrite and rework, say, 14 policies rather than rework one policy. And that degree of deadly policy in the UK is currently one of the problems that the UK is experiencing as it tries to negotiate its exit from the European Union. It's trying to unravel many different policies rather than a single policy strategy. So what lessons do we have from developing countries? Air quality policy must be linked across a whole series of different policy arenas, and what we need to work on in ASAP and other developing country contexts, what those policy arenas happen to be for each of our core target cities. And the expectation is they may be different within each of the 3 cities we are working on within ASAP. So developing the best solutions for Kampala may not be the best solution for our other 3 cities within our project. Now we move on to the final bit of my presentation. Now, urban diagnostics may be, or should be, I expect, a word that is new to many of you. And this is a strange issue. If you do a word search within the academic literature for papers in urban diagnostics, you find none. If you do a word search for the word diagnostics in cities, you find one paper. Now, most of the ways in which urban scholars study cities, they're looking for predefined problems. So they're looking for concentrations of deprivation. They're looking for concentrations of underemployment or overemployment. The problems have already been defined either politically, within the policy debate, or within an academic argument. No one actually treats a city or a city region as a patient, if we take the analogy, because diagnostics are using an analogy for medicine, so we're assuming that our city has some problems, but we don't necessarily know what those problems are. So we're not assuming that it's a deprivation issue, we're not assuming it's an air quality issue. Let's just say city is patient, we're trying to understand what the core challenges are facing that patient, and then we're going to test those challenges using a set of medical diagnostics, or in this case, data-driven diagnostics or analytics. So this is a very different way of considering cities. So what we want to do is utilize the process of urban diagnostics within the ASAP project to move beyond a siloed approach to air quality policy development towards identifying something that is more integrated. So the urban diagnostics should hopefully illuminate those policy areas that we need to begin to work on to develop or integrate air quality within those policy domains. Now, this approach comes from a project that was funded in the UK and finished earlier this year. It was an unusual project because we had funding from every single one of the British Research Councils and Innovate UK. And within this project, we developed this urban diagnostics approach, and we applied it through the city of Birmingham. And what we're planning to do in ASAP is take some of the processes that were developed on Birmingham and try and apply them in an East African context. So the urban diagnostics approach copies or builds upon debates that have been going on within medicine for many years. So it takes a medical approach to diagnostics and applies this to cities. Now, within the world of medical diagnostics, when you visit your general practitioner, if you can manage to get an appointment to see a general practitioner, the first thing your GP will do is look at you and observe you as you're entering their room, and they will begin to make a judgment of what's wrong with you and whether there is anything wrong with you. And they're engaging in a process of qualitative diagnostics. In many cases, they don't know what they're seeing because it's automatic, and they're looking for signs that they will have been acquired how to read those signs over 10, 15, 20, 40, 50, 60 years, depending on how long you've managed to survive within the National Health Service setting of the UK. Now, once they have made that qualitative assessment, they then may decide to test it, and that's when they will begin to engage in a whole series of tests, might include blood sampling or whatever it might be, to try and determine whether their initial qualitative diagnostics is correct. Now, if we apply that approach to cities, what we can do is we can do a qualitative diagnostics, which begins by identifying and analyzing the policy documentation for a city. So this is analysis of every single policy document that's been developed for Birmingham since 2010. And what we do is run a network analysis on all of the keywords in those documents. And that network analysis identifies two things. One is that you can identify a set of core policy areas that this city has been preoccupied with. Now, air pollution is not within that core. So air pollution is to the side of that policy debate. Is it possible to use an arrow on this so that people can see? So use a mouse. So air pollution is over here. So it's not within a core part. If you can see that arrow, it's not within a core part of this policy debate. Now, the other thing we've done for Birmingham is we've identified every single academic paper that's been published on Birmingham for the last 10 years, and we did a similar network analysis. And what we discovered is that the policy documentations are not heavily engaged with the academic debate, because the academic debate actually is up here, and there's no connection between the world of policy and the world of academic debate. Now, the reason for that is that the academic papers are very narrow, and the challenges that are facing the city and that are being debated and discussed by policymakers are much broader. So there's a misfit between the scale of which academics are imagining and researching the city and the policy needs of the policymakers that are working within Birmingham. Now, an example of that is one paper that's sitting up over here, and it's a paper about it's a medical paper, and as not being a medic, my description of this paper may be slightly strange, but my reading of this paper it is, when should one shake hands if you're on a bus in London, Birmingham, Manchester, or Newcastle? And it's a paper on fecal contamination of hands by people on public transport. And for the UK, it's okay to shake hands in Birmingham. It's much better to shake hands, or safer to shake hands in London. Never shake hands if you're in Newcastle if you're using public transport, given the apparent absence of hand washing. And that is a sample of men. So women we don't know about, men you should be wary of. Now, the qualitative diagnostics we have done for Birmingham identifies a series of core challenge areas that the policymakers think are particularly important. And what we identify is areas in which there are parts of the city in which there are 10, 15, up to 30 policy documents, and other parts of the city where there's nothing. There is no policy debate. So we can identify areas of the city in which policy is hot and areas of the city in which policy is cold. What we can then do, now this is where just gone way ahead. You can also do this network analysis of the qualitative documentation in a very different way. So here you have all of the topics that are under debate around the edge of this circle, and you can see all of the links and connections between the documents. And you can see the blue lines are the academics, and the other lines are the non-academics. As you can see, academics talk to academics, they tend not to talk to policymakers. So one of the things that comes from this analysis for ASAP is to make sure that the science, be it the atmospheric science and the social science, does become greater embedded within the policy networks and circuits that are going on within our three cities. What we don't want is for someone to do a network analysis of the policy documents in 5 years' time, post-ASAP, and for us to have these sets of blue lines, because that will mean ASP has been relatively unimportant for shaping policy in these three cities. It might be good for academic CV, but that's different. So how do we develop a sort of more integrated systemic approach to urban diagnostics? So the first thing we need to do, if we're going to do this correctly, is it's multidimensional. It tries to bring in as many data sets as possible, and the data sets ideally need to be geocoded. We're dealing with different forms of analytical layers. We're trying to understand everyday practices so we can put in some interviews into this process, and those can be interviews with residents, with households, and with policymakers. We're trying to understand routine behavior that is operating within the city and how that routine behavior can be nudged so you get better outcomes, and those better outcomes produce better air quality, given the focus of this particular project. And we're also interested in adaptation strategies. How can one engender people and companies and policymakers and politicians to alter their behavior so we get better outcomes? So all of this is about layering different data sets. Now, the second part of an urban diagnostics process brings us into a data issue. Now, for Birmingham, what we were able to do was identify 258 data sets that have something to do with Birmingham. Now, what's interesting about this, and it's going to be the same for each of the three cities we are working on within ASAP, each of those cities will have a set of data sets, but those data sets may not be up to 258. There may be 358, or there may be just 12 data sets. Now, for Birmingham, there are things to note as soon as we got into the data analytics. First, all of these data sets are siloed. So we have data about housing, we've got data about air quality, we've got data about movement, we've got data about the economy. Each of these data sets is a separate data set that is being developed for a particular purpose. Now, for Birmingham, no one had ever brought these data sets together into a formal process of diagnostics. We did this for the Birmingham project, but I'm not going to talk about that outcome this morning. So the key thing that I want to put forward is that the urban diagnostics process that we're trying to develop through ASAP and applying it to emerging economies has two particular needs. First is the identification of the qualitative evidence base for the city. Now, to do that, we need to identify all of the relevant policy documents and engage in the sort of network analysis we have done in Birmingham, but for our three target cities. Second thing we need to do is identify a series of core individuals who we need to target for interview. Some of those interviews may be about understanding the ways in which policy is created within these cities and what are the critical policy areas. But some of those interviews may occur after we have completed this process of diagnostics, because we would then present the diagnostics back to the policymakers to try and work out or try and shape the ways in which they consider how they treat this policy arena in the ways in which they are constructing various policies now and in the future. So one of the things you will see from Birmingham is that we've got areas in which there are very limited data. So data availability is very difficult, or it doesn't exist. So the graph to one side of this PowerPoint slide, the bars indicate areas where there's lots of data and areas where there's very little data. And as you can see, sustainability, resilience, resources, various things to do with water and waste. These are areas with relatively limited data sets, and areas where there's lots of data sets reflect the political interest in particular challenges. So energy is a key issue, housing is a key issue, health and well-being is a key issue, income, poverty, unemployment are key issues. So what we don't have is a rigorous and robust evidence base for a city like Birmingham, because the evidence base we have reflects decisions that are made by politicians, and those reflect the decisions that they make to ensure that they may be elected at the next general election. So that explains where we have what we call hot areas for data access and areas where there is no data because no politician has actually called for that data to be created. So the work packages that we're involved with, so Lauren, myself, and Hakeem, primarily 1 and 3, but there's also a link into 5 in terms of combining the data sets and the variables that we will identify from the quantitative analysis with the air quality data in work package 5, so that all comes together in work package 5. So what Hakeem will be requesting our African partners over the next couple of weeks is 3 things that we need to sort of co-create to understand air quality from an urban diagnostics position over the next 18 months. The first thing is the identification of the policy documents, and I know that some of this identification has begun to happen through the work of William, but also through Hakeem's very productive first 2 weeks on the project. But we need to make sure that we've identified everything we need to identify for that stage of qualitative urban diagnostics. The second thing is this development of this list of individuals that the ASAP needs to interview. And those interviews may be undertaken by some people coming from Birmingham to East Africa, by our African partners in the field, and they may not necessarily be organized and controlled by work packages 1 and 3. They may be interviews that are being run out of some of the other work packages. So we need to coordinate that interview process. And the third issue is to identify the data sets that exist for each of these 3 cities, focusing on data sets that have some degree of geocoding within them, because with that geocoding, we may be able to bring those data sets together into a common analysis to develop this urban diagnostics approach for the city. And that's the end of this presentation.
Many thanks, John. I'm conscious, we have been some issues with some of the colleagues participating to this webinar who can't actually hear the presentation. So what we're going to do is, of course, it's recorded. So really, please go back to the recording if you have missed any of the presentations. Saying that, we're now going to move to our second presenter. We're going to take the question at the end. Yes. So we're going to move to our second presenter, Dr. Mahapatra, who will talk through his work on population dynamics, air pollution, and public health. And as just mentioned to one of our colleagues around this table, we will take some questions, but after the second presentation, just being conscious of time. Can I just ask Dr. Mahapatra? Right.
Yeah.
Do you hear us? And we can hear you.
Okay, thank you. So with me, my colleague Monica is here. So we both will be jointly sharing the work that we are doing here. So can I go to the next slide, please? Yeah. So everyone knows that India has been at the focus of the air pollution kind of thing. Every year around so many people are suffering from different public health diseases only because of air pollution. And it's ranked as one of the top risk factors for ill health in India. Every year millions of Indians are dying prematurely as a result of the exposure to air pollution. Most recent estimates of the global burden of disease is that 25% of all deaths are due to air pollution. And while there can be many causes to this air pollution, if you look at more critically, okay, and analyze where the air pollution is increasing rapidly over the years, the cause is mainly due to human activities, which is contributing to the urbanization, infrastructure, and hence resulting in more air pollution, both indoors and outdoors. The rapid increase in population growth has resulted in faster urbanization, and which has adversely elevated the quality and environmental degradation. Next slide, please. And all these things, while the cause and effect is very clear, okay, the air pollution is having significant impact on the public health. So, to give a context, how the changing population and the urbanization is happening in India itself, we looked at the trend of the data from the census primarily. If you see, the India's annual growth has been around 1.2%, okay, annually, and it's going to be one of the most populous country across the world by 2020. And currently it is the second most populous country in the world. With this population, what is happening? If you see the block boxes, it shows the number of towns that the weight is increasing. Where in 1950s only less than 3,000 towns were there, it is now goes to 8,000, and it's expected that this will be touching 10,000 very soon. Actually, next decade of in next 20 years. At the same time, the rate of urbanization, which was around 17% in 1950s, now it will cross more than half in next by 2050. Ultimately, the next graph, the below graph, which shows that not only the rate of urbanization is increasing, the size of population in these urban cities, which is increasing rapidly. So if you see the top portion of the green colored one, which was only about 40% initially, now it is going to 60% in 2000 up to 2001 census, and which will go further in the coming days. So what is happening with all these things? The urbanization is increasing the emissions, particularly the carbon emissions, and it's contributing to the air pollution. Not only the carbon emission, but other hazardous gases also. Next slide, please. And this is one diagram that we have taken from another report who has done the work on projecting the kind of carbon emission that is going to happen with the population increasing. Okay, and it clearly shows if we do not do anything on the population front and do not do in the air pollution anything, it would reach somewhere around 7 gigaton by 2050, which is really terrible. Next, please. So this is something we have taken a simple example from an Indian city called Agra to see over the years how the population is increasing and see the air pollution, particularly the PM 2.5 is behaving. So it clearly shows the linkages. We have done some preliminary correlational analysis to see whether there is any relationship exists or not, and it shows that as the population grows from year to year, the PM 2.5 level also clearly increases. And it shows only crude relationship, but we need more sophisticated analysis to prove this actually. Next, please. So how all these things are working? We say there have been definitely evidences has shown that the air quality is affecting the public health. Then the causes of air pollution has been shown by the research. Everything has been there. So what are the pathways? The pathways is that the changing population, which is mainly due to birth, mortality, and migration. It leads to more urbanization. And with urbanization, what happens? Rapid industrialization, deforestation, depletion of carbon sink, and more use of luxurious items leading to more emission of hazardous gases, which is contributing to the poor air quality. As the poor air quality, again, the public health impact is happening. So all these things are, it is a vicious circle kind of thing. The public health again fits into the population side, the population dynamic itself. So you cannot, what has happened till now, it's all, people have done systematic piece by piece research, rather looking at the whole vicious cycle into one group. Next slide, please. So with this background, the objective is that we are going to look at this whole dynamics in one system, fit a dynamic model, and see where this intervention would lead to more impactful results kind of thing, and what level of that intervention is required. It is at the control, like the population level, at the system level, or at the public health outcome level. At which level the intervention you should do, and to what extent you should do actually. For 5 years, 10 years, to what target group you should focus. That is something we are going to look into it. Thank you. Next slide, please. So there are several other models, okay, to look into this population dynamics and air pollution and public health outcomes. While there are several, the two most famous one were the IPAT model and the health impact assessment model. Both of them take into account different factors, but the key problem is that they do all compartmental models, and they do not consider this dynamicity of these different parameters, which keeps changing from time to time, and the interlinkages between them are very dynamic, depending on multiple other factors. Suppose, for example, you are doing a public health intervention, okay, and you are trying to reduce some this premature mortality, but if you do an intervention on reducing air pollution, it may not be sufficient. There are other systematic factors that needs to be taken into account. So system dynamic modeling is one such approach which takes into account this dynamicity of the problem and also looks into the optimization issues, how the optimum solutions can be achieved through this. Thank you. Next slide, please. So what is system dynamic model? As I said, purely mathematical modeling. The best thing is that you can develop your equations. If you and these equations are completely based on the theories that you. So first thing, the basic thing that you develop a theory. Look at the relationship which you in the as for a theory of change, what you believe it should be there, and then define those relationships, how the different factors are related to each other. And as I said previously, one factor may be affected by multiple things, and one may be affecting multiple other things also. So that is the best thing it does. Second thing is that it uses a set of differential equation, and hence it takes into the historical data and looks at the rate of change into this one, and that's why it is very comprehensive in that way. And it has potential to it has been applied into different engineering settings, health system strengthening, and I see the potential basically in more complex issues as such. Next slide, please. So why SDM to air pollution? The key is to find the intervention points where it can be really effective. Second is that earlier models, as I said, has more complex. Okay, it is not that SDM is not complex. SDM is equally complex, but it gives a better solution to just compared to the other models. That's the thing. At the same time, it helps developing different scenarios like any other model. That's the best thing. Also, the thing is that it will tell you in which group of intervention you definitely need to focus to achieve the optimum level of outcome. Thank you. Next, please. Yeah, from here, my colleague Monica will share.
Thank you, Vidhu. So, our experience in development of system dynamics model teaches that proper understanding of the model behavior is very hard to achieve if the approach to development of the model is not gradual. Therefore, in developing the systems dynamic model, it is very crucial we go step by step. So what happens if we follow all the steps in the gradual manner? It helps us to develop the model with a better understanding of the behaviors which are taken at each and every cycle of this stage. So the very first step that is in that we use in the development of the model is conceptualization. Conceptualization includes defining the purpose of model and identification of the key variables, describing the behavior or drawing the reference mode of the key variables. So here reference mode is the set of hypotheses that we define graphical representation based on the historical behavior of the variables or the assumptions that we see a particular key variable to exhibit in the future. Once you identify your key variables, the next step is to define basic mechanism, feedback loops by developing the causal loop diagram. The one such diagram is presented over here. If you can see, all the key variables are characterized by the loops and the arrows. These basically shows the linkages between the different variables and how they are related to each other. After conceptualization, next comes the stage of formulation. Formulation takes place making use of the differential equation, estimation and selection of the parameters, defining the units to every level and rate. For example, if I have the population size, I need to define what is my unit. It can be the number of people per year. If I am including birth rate in the model, I have to assign units to the variable. So once I assign the units, then next step comes to the checking of the model whether it is balanced or not. So by balancing, we mean whether all the units defined match up to the set of equations we have defined. After formulating the model, it is simulated or run to test the set of hypotheses and model's assumption. The model is also tested by making changes in the parameters to test its sensitivity to the disturbances. Lastly, when your model is all set up with the parameters defined, equations defined, and the interlinkages defined, we use it to estimate and to test to the response different policies, translating the insights for implementation and dissemination. Next slide, please. So far we have completed the stage 1 of the modeling, and here we are presenting the causal loop diagram to show relationship between key variables one by one. This segment of the causal loop diagram characterizes the positive relationship between population size and urbanization. That is, the increase in population size will also increase the urbanization. A link marked positive indicates a positive relation, that is the arrows in green, and the arrows in red exhibits negative relationship between the variables. For example, increase in fertility is going to increase the population size. Similarly, if we notice the mortality, it is a red in color that exhibits the negative relationship. A negative causal link means the two nodes change in opposite direction. That is, the node in which the link chart increases, the other node decreases, and vice versa. Here, if the mortality increases, the population size will decrease. Next slide, please. So in this part of the causal loop diagram, we show how the increase in urbanization is contributing to the increasing air pollution. If we focus on the extreme left part of the diagram, we'll see that increase in urbanization has multidimensional impact on the environment. It has led to increase in infrastructure development that led to increase in land extensification to provide more land for housing, roads, construction of highways and power plants. That has reduced the amount of land for cultivation. Since the number of mouths to feed is increasing and the cultivated land is less, more intensive farming techniques are being deployed with increased use of pesticides and fertilizers. To clear the land for next set of farmings, the crops are burned. Ultimately, what happens, the emission of smoke and gases through crop burning or the reaction of released pesticides and fertilizers, there is release of hazardous gases and smoke into the environment, which contributes to our problem of air pollution. This is the one segment that we just spoke about, that is the land extensification. Similarly, some of the other factors that contributes to air pollution due to rapid urbanization are increase in deforestation, depletion of carbon sink, use of ACs, freezers, space and water heaters, increase in the number of vehicles on the road, and industrialization. Next slide, please. Here in this loop, we present the segment of the causal loop diagram that depicts the relationship between effect of air pollution on deaths due to exposure to the hazardous gases and emissions. As the air pollution increases, the exposure to polluted air also increases, which makes you susceptible to health risk. You'll fall sick. And as a result of falling sick, what will happen? People will either die due to premature death, and it will have economic implications in terms of wage loss from work or out-of-pocket expenditures. Next slide, please. So while we presented different parts of the model of the causal loop diagram separately, here we can see everything together, that how population size is affecting the urbanization, how different segments of urbanization are contributing to the air pollution, how air pollution is affecting the health of people, and how the deaths due to air pollution, the premature deaths, is also impacting our level of population size at any given time point. Next slide, please. So these are two illustrative outputs that we can make using the model. Figure on the left shows the reduction in population susceptible to disease caused by air pollution over time with the varying levels of afforestation programs. And the second graph here depicts the reduction in suspended particulate matter levels over time if the interventions are in place to put ban on diesel, adoption of solar energies, or if strategies like odd even vehicle use is in the place. I would like to emphasize over here that these are dummy outputs and they do not reflect the true scenarios. Next slide, please. So, till date, we have completed our causal loop diagram. The one we presented here is not complete. There are some other segments that can be added to it, such as the different interventions and its effect on the air pollution. And some of the key next steps include identification and mapping of the indicators, running of the data with running of the model with actual data to estimate the impact of population growth on air pollution, identification of the routes which are most likely to contribute in the future, and to identify impact of different initiatives on reducing air pollution under different scenarios of population dynamics. So that's all from our end. Thank you.
Thank you very much, and thank you to our presenters for these very fascinating presentations. So we still have a good 10 minutes to take some questions. So if I could just remind everyone to use the chat box, so the speech bubble at the top center of the screen, to ask any question. I'm aware our colleague here, Neil Thomas, has already a question, so I'll just hand it over to Neil. And meanwhile, if you could just ask your question on the box, and we'll just read them, and then both presenters will be able to answer.
Thanks, Lauren. John, you highlighted the problem of the academic papers largely being for academic researchers, but how do you address that? Because even if you're writing sort of policy-related work, it's still going into more academic-type journals, and so it's still going to a different audience, but still an academic audience.
Right, that's one of those interesting questions. How we're addressing that is working with the new UKRI unit, and we are developing a document for them, which ultimately means brochure. And the brochure is to try, and it's targeting the senior management teams and the head of the UKRI to make them aware that some of the research calls need to be broader to reflect the challenges that policymakers are engaged with. So rather than actually saying that we need to write our current papers so that they are targeting policy, to have research calls that are actually targeting broader challenge areas. So rather than having a research call that is just about health, a health call might need to be involved in other policy domains, in the same way that an economic call might also need to have within it an air quality or pollution call. So to have a sort of broader, more policy challenged approach to some of the research calls that are coming out of the UK research councils. Now that is probably an easy win, given that the merger of the research councils into UKRI is partly to do with that. And the projects that this comes from, we were part, the Urban Living Birmingham project that Open Diagnostics comes from was one of 5 pilot projects that were the first projects to be funded in the UK that had funding from all of the research councils. And the document that is being produced reflects the experience of those 5 projects. And those 5 projects all exhibit the similar mismatch. You know, this is what academics say, but policymakers aren't listening because you're talking at a different scale. Narrower scale, broader scale. So it's partly understanding an impact agenda. Now, whether this is going to work, I'll tell you in 10 years' time.
Can I ask the next question? Yep, so I'll just pass it over to Eloise Murray.
This is just a brief follow-up question to John. Did you look at the reciprocal where there are sort of policy-driven reports that have academics involved as authors?
The analysis was anything on Birmingham that included the networks of, so we're interested in how policymakers were learning, where they were learning. Now the problem with our approach is that they might have been learning, but the learning may not be documented in the documents they were producing. Because the learning could have occurred 5 years ago in a chance conversation with Neil, but the chance conversation then becomes dilated and diluted in the documentation, so Neil is lost. And we couldn't pick up any of that.
Francis Pope.
Hello, thank you everyone for great talks. So I had a question mainly to Bidou and Monica, but potentially to John as well. So this link between population and pollution, have you looked at how your age demographics within your population affect your pollution? So I guess at a first order, I'm guessing the pollution is a function of consumption, and consumption will certainly change depending on your age. And we know that these cities, both in East Africa and also in India, their demographics are changing rapidly. So have you looked at that sort of granularity within it?
So actually, as of now, we have incorporated it into the causal loop diagram, but certainly that is something that can be further simulated and run. And as far as different age groups are concerned, yes, you can see the impact of air pollution on each of the different segments separately.
Yeah, I will add further Francis on that. Yes, as I said, historically how the structure is changing, that is something can be incorporated into the model. So in the causal log diagram, it is not possible to show that kind of changes, but when you build the model, actually we can build those things. In the formulation, the age or by the sex composition, we can incorporate based on the historic trend, or if there is certain estimation, or we expect the population to behave in a certain manner over the next course of 20 years. Based on that, yes, all that information can be included.
Thank you. I'll just leave it to John to answer.
Right, so that's the perceptive question. So if you want to understand cities and economies, you need to understand consumption patterns. We've been doing this on Birmingham, because as the population changes in terms of its ethnicity, so different ethnicities will spend in different ways and have different consumption patterns. And as the population ages in particular bits of the city, the consumption within that part of the city changes. Younger cohorts tend to spend more locally. Older cohorts tend to spend elsewhere. So you can see within the British case, younger household with family, lots of local expenditure linked to that family. Older retired household spending part of the year cruising in the Med. So different forms of consumption expenditure, or not spending at all. It's the other issue with older households. They decide that they don't need to replace now because what they have is going to last them out until they die. So either do they need a new dishwasher or a new suit, so they don't spend. So we do need to know an awful lot more about consumption behavior, and that's one of the things ASAP will need to do during some of the household interviews, because the UK data is pretty weak for individual household consumption. So if we can do something slightly more sophisticated than the UK data in our 3 cities with a small pilot study in some of the interviews, we'll be doing pretty well.
Thank you, John. We have a question from Michael Gattari, and then I will pass it over. Oh, okay. I'll just pass it over to Neil Thomas for a very quick addition, and then I will read the question from Michael Gattari.
I think the other aspect also, just as Eloise was pointing out, age-related susceptibilities as well. And these things are not linear, as you were pointing out, John. You know, the early ones are basically the most susceptible die off quite early, and the survivors are probably more resistant. But at the same time, the older they are, the more comorbidities they have, which also then increases the problem. So it's quite a complex issue, and how we document that, I'm actually not really sure at the moment. Yeah.
Okay, I'm just going to read the question we just received from Michael Gattari from Nairobi, and I mean I'm guessing probably both presenters can probably answer, but it would be good maybe just to have the view of our Indian colleagues first. So the question is, what impact will the fast-growing informal sectors and unplanned housing structures have on air pollution? Hello, do you?
Yeah. Monica, you want to respond?
Yes.
Yeah. So, based on a literature review, we have observed that these unplanned sectors, the growth as well as in the housing structures, the unplanned. So, if at this rate everything continues, the level of air pollution and the ambient air quality is going to deteriorate, and this is something that we can put a control on to see whether how much impact of the control, some intervention is taking place to put a curb on the rampage of housing structures. That is something that we can notice and answer to our analysis.
Yeah, further to add, the fast-growing informal sector and unplanned housing structure. Take example, I can tell my experience from Delhi. So when some decades ago, when Delhi did not have this kind of buildings, tall buildings, okay, the air was flowing continuously, and air pollution was not a big problem because the dust particles are flowing to other parts. Now with unplanned this buildings, housing structure, what has happened? The air is not able to flow properly, smoothly, and that's why the dust particles are stagnating over the city of Delhi, and that's why it contributes to air pollution. The informal sector is another big issue because you do not have any control about what kind of emissions they are leading to. Okay, not only to air pollution, it's also to the water pollution. What kind of poisonous materials they are leaking. So it has implication on both actually that way.
Thank you very much. What I'm going to do is probably read the other question we received, and I'm going to assume this is probably going to be the last question just because, conscious of time, we're supposed to finish in the next sort of 3-4 minutes. So I'm going to read the question, pass it over again to our Indian colleagues if they have any sort of further comments to make, and then leave the last words to John, and then I will just do a very quick concluding summary. So the question is, any data findings related to the perception on air pollution risk amongst policymakers in the UK, developed country, in UK cities, and or in African cities, developing countries? Sorry, we're just dealing with unmuting our colleagues in India. Do you have a view on this? Do you want to answer first before I pass it over to John?
No, I don't have a view on this.
Okay, so I'll just leave it to John for just a few concluding words, and then we're just going to end the webinar.
Right, okay, so let's just deal with that question itself. A number of local authorities have released questions that are in citizen surveys. And these are surveys that go out once, twice, 3 times a year, depending on the local authority. And some of those have specifically asked citizens to rank challenges they are facing, and air quality is sometimes included within that. And it usually comes out from the ones that I've seen, 30%, 40% of households see it as an issue, but not a major issue, because the major issues are the things that they can experience directly. So you're unemployed, or you've got problems with benefit, or you've got problems accessing health services, or social care, and the equal linked to relations to do with congestion and movement within cities, rather than some of the more insidious and more deadly aspects of air quality and air issue and air pollution. And my final point is that the 2 presentations we've had this morning or this afternoon, depending on which time zone we're in, are reflecting different approaches. So urban diagnostics is about identifying the areas that are going on within a socio-economic system that would contribute to a particular problem. You would then take that urban diagnostics analysis into a model, and you would then model that which comes out of the diagnostic. So these are complementary approaches. The primary difficulty that I faced with urban diagnostics, thing that means that I don't sleep well at night, is that no matter how well we were able to do this, There will be processes that we cannot measure because we have no data. And those processes that we cannot measure might be the most important aspects of understanding some of the causalities that exist within the systems of systems that are involving in air quality and its wider direct and indirect impacts. So one of the things we need to be minded with in ASAP and in other air quality projects is to try and identify that which we don't know and that which we cannot know because there's no data and the data can never be assessed and never be collected.
Thank you very much, John, and thank you again to our presenters and to all our audience here in Birmingham, but also in different places in the world for all their active participation. So just a quick reminder that the information about new activities and the next set of action, you will receive the PowerPoint from Francis by email, so you will have all this information coming up. And also please visit the website where we have published a range of new documents, so really revisit the website and check also the Twitter account for any information that you want to have on the project. And also don't hesitate to advertise the website and also the Twitter account across a range of other networks. We're really interested in gathering even more connections with other countries. So many thanks again. Just a reminder as well that the next quarterly webinar will take place in September. You will receive a newsletter in August with a set of information and things that will happen and have happened and will happen in the next few weeks and months. And as usual, any question, you can get in touch with us. And again, do visit the website if you want any further information. So thank you again. And until the next webinar, goodbye to everyone. Thank you.